Today we are going to do a reinforced concrete structure design, a real life project in RFEM, that is the DLUBAL software. So the first thing is to open this model in AutoCAD, this our architectural drawing. Then you're going to do the general arrangement. From my general arrangement, this building can see the ground floor plan, the first floor plan, the second floor, and the third floor, and also the fourth floor, which is the water tank detailing. So we need to do the general arrangement to be able to model. So the general arrangement basically determines the positioning of your column, which is usually at the corner of the building to begin with. The staircase, this position should be having columns, and the intersection between walls and beams, there should be a columns to distribute the load from the slabs to the beams, then to the columns. So this column is carrying the load from this beam, this beam, this beam, this beam, then transferring the footing, which finally distribute the load to the ground. So this is my general arrangement. Basically, this is a position of my columns. I have already precise my columns. I will be using 250 by 250 columns, and I'll be using for this position where this is going just up to the second floor, and for the other positions where it is going up to the third and also to the fourth floor, I'm using by a 300 by 300 column. So I'll go to RFEM. I'm using BS 811, so I'm using load BS 55950. Make sure that my Z is download, and then okay. Okay, my name is missing, so then I'll RCC building design, then okay. Just click OK. So if you go here, you can see my building has, I can model halfway because I have similarity. So you can see this polyline. So this polyline going this way is similar. If I can mirror it, if I can mirror that polyline about this axis, okay, no, you can see this polyline, you can see there is similar. This is similar to this. So I'll not need to model the entire building. I'll just model up to this, up to there. And then this design, I will mirror it to the other part when I'm doing the detailing. So I will just assume that the design of this is similar to the design of this. Only for this column, don't forget this column. When I'm modeling halfway, the software might be assuming that this column are the edges, are column at the edge, which is not the case because this column is also carrying the load from this slab and also from this slab and also from this beam. All right. So this column, I'll also mirror this, the design of these columns here to that part. And also I will mirror the design. These columns are now at the edges, so I'll mirror to this part. This column will just be the same to these columns and such. So I will mirror it, I will design, I will model halfway, then mirror the design. So we'll go to our frame. I can go to that axis, XY axis. Just try to change this. Okay. Then I can insert graphically. So let me insert guidelines using my dialog box. So I will start by 3.72 meters, this one, and also 5.1 meters, 3.72, 5.1, then change here. Number one is at 0. Okay. Number 2 is at 3.72 meters. Apply. Number 3 so based by 2 points. Number 3 is at 5.1. 5.1 plus 3.72, that will be 8.82. 8.82 meters. Then apply. Now I go to X1. So I will be using this starting by 3.7. This one is number 1 or number 0. Apply. And then again number, that is, so I will change to B. Number 2, let's change number 2 at 3.7. Repeat new guideline. Just repeat. Right click and repeat. And then number 3 should be at this is 6.3 because this plus this 6.3. 6.3. So let me say number 6. No problem. Number 7 will be now 6.3 plus 1.5, that will be 7.8. 7.8. All right, now again 1.325. Okay, 7.8. That is 7.8 plus 1.325. That is 5 to 1 carry 1 7 8 9.125 because I'm doing equation manually. 9.125. Okay, plus again 1.3250 4 10.45. 10.45. So apply. Finally 10.450 plus 1.5 Remember when you're designing your modeling manual halfway. Now you can see this. Actually, the dimensioning are varying, right? But you can see if I assume this to be similar, it should be 1.5 meter. These are 1.5 meter because my units are in millimeters. But this one is less than 1.5 meters. So if we increase this, remember the architect is always right. He should follow his plan. Maybe from the architect, the ground is well this fits up to the perimeter well. So make sure you do not increase this one. So maybe because this allowance this should become here, and then should be this one will be similar to this 2.6, and then this will cover for that. But anyway, when we're doing the design, this is very small. The design, it will not much affect the design. So just let's use 1.5 meters. That will be 0.59. That is 11.95. 11.95. And apply. Then okay. Then I'll come and insert model data. I will insert new single member. Member type is column. Then create new cross section. To 50 by 250. Change here material to concrete. This concrete. Okay, the standard will be VS. Okay. So I will insert it here. So this one will be 0, 0. This one will be 2.85. All there. It should be negative 2.85, 0, 0, then 0, and apply. Now you can go to 3D. I will delete one of these columns. So again, single member. Okay. From there. Then edit, move, copy. Just pick points. edit, edit, copy, I want to copy, edit, copy just one, and then pick points, copy, pick points, edit, copy. So I will edit and then copy, then just pick points from there, there, apply, pick points again from there, there, apply, pick points again from here, here, apply, points from here, here. Let's see our general image. Okay. Close, then let's see the 3D view. Okay, edit, move. Now 0, negative 2.85, 0, 0, and apply. So this one I need to delete it. This one is not there. So I will copy this. A distance of 3.25, 3.72. Edit, copy. Just make sure it's one. Direction Y. Z is 0. Y is negative. That is 3.72. Apply. Again 5.1. Now this time I will uncheck which ones. I will uncheck this and that. Holding control. Edit, copy. 5.1. Then first apply and then okay. Okay. Tools. Generate. I want to generate So add on. I want to generate a stairway. L2 is 0 meters. B3 1.2. B1 1.2. Flight length is let's say 4.5 meters, 2.85. One point two, 4.8, 4.4 meters, or let's say 3.9.2. So let's not model the staircase. Let's model our beams. or 450. Okay, change the zone to beam. So this one should just be deleted so that model again dot what be when inside model data, inside node support dialog box, rigid. So I need to select the nodes. Okay, okay. Model beam, that is slab 150. Okay. Okay. That point, and back to the original. Why am I able to do that? Is because this one is polygon. If I change to rectangle, okay, just need to pick. Okay, okay. Pick the diagonals. Okay. Now this one should just be deleted because there's a staircase there. And I'll select all the beams. Double click and go to options. Member eccentricity, I will add then to a surface, and then pick the surface. Okay, so that the beams will move down. So I don't know what is this. We'll just delete it. But the error could be here because this beam is not going all the way. So delete that. Don't know what is that. So let me undo what I just did. So I think we actually there's a problem because some of our members so I will delete. Okay, let me undo this. Okay, so I'll put that on that. I want to move it by 1.5 in the x direction. Just 1.5, 0. Okay, so I will activate to draw my beam. You can see the trouble simple modeling error has brought us 150. So we don't need plug there. So I will select all the beams. And then holding Control right click there, go to options. We create a new, so there, surface. There is only one surface. So that we move all our beams below like that, okay? Again, we have an error there. So let me just delete that node, okay? Again, there's a node there that we don't want. Again, insert a surface. There, 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 there. Okay, again, select, double click option, so that we move it below. Okay, so I will add my loadings, surface load. So first thing is to add the load cases. We need to add the load cases. The first load is self-weight. Add new, create new load case. In post. Then we can add new case or wind. So this, make sure you uncheck here, because the only self-weight can be. Okay. So I will add surface, dead load surface, magnitude of about 1. That is for finishes. Okay. That is for finishes and everything. And I will change this to live load, in post load. Then I will add surface load for a room about 2.5. Then I will add line load and add line load. $22. That is for landing. Okay. So here it can be half of it, because we have one landing, should be 11. Okay. Now I'm not going to add the wall loads. Why? Because I'm assuming that because this project we did is from Kenya, if you are using load-bearing rocks or wall and the wall is not suspended, then you are going to design a strip foundation. So you are not going to load the wall load into the beams. Therefore, for example, if you see this work we did here, you can see we have designed a strip foundation, right? Because the rocks are from Bahati Barrow pit, and the crushing strength of the rock is 7 kilonewton per meter squared. Hence, the wall will be considered load bearing. So if you go to the beams, you realize in this manual design, we did not load beams with wall load. So the beam load shall be from slabs and slab live load only. So we are not going to add the wall loads here. And I'm going to compare with actual design which you did manual. So I'm going to copy everything again. Then edit, I'm going to copy by -20 2.85 in the Z direction. Now 0, just number of copies 1. Okay. I will uncheck a few columns here. I'll uncheck this column and that column. Uncheck that beam, that beam, that beam, that slab. Okay, this beam, this beam. Okay, uncheck that. So I can go to visual interrogation and view by selected objects only. Visibility by selected objects. Okay. So I need to unselect all of these. Okay. Now I can just edit these live loads. Just double click, change it to roof about 1.5. Let me cancel. So first we will need to copy. I will uncheck this and that. Again, check this and that. Then I need to copy, edit, copy again that direction. Now this time, I will change these ones because just for the roof, the roof load should be just 1.5. 1.5. Okay. Now when it comes now to dead load, self weight. Now we will insert, because we're having 3 tanks here. Now from the calculations, each tank is carrying 10,000 liters, which is basically mean 10,000 kgs, because remember the density of water is 1. To change into kilonewton, multiply by 10, to change by gravity to change to newtons, that is 100,000 newtons divided by 1000 become 100 kilonewton. Now divided by the area, the cross-section area, you get that the surface load there should be about 14 kilonewton per meter squared. So I will add a 14 kilonewtons. 14. Okay. There. There. And there. So I will again select all of these on that beam, edit, copy, again just one time, then edit, copy, then this time now we will add slab 150. Okay, now insert surface 14 for water tank again, and then impost load of 1.5 again. That is, my impost load is not all this. I will double click and change it to 1.5. 0.5. Sulfate, so that is okay. So I'll go again to view, cancel visibility mode. Again, in our rooms, I will add a self weight of 1. Just 1 for finishes in this second floor. Now if I go to impost, okay, again I can just pick all these columns, again edit, copy. Okay, these are going to the roof, and just delete these lines. Then from here you can maybe model your roof if there's any need. So I'll come to tool, model, generate model. I'll generate truss. This type of truss. Pick the first point is here. Pick the next point is there. My truss I will change this one to just timber. The timber has maybe how many millimeters? 10 by 20. Again, I can just copy, pick points, there, apply. So you can just like that model your truss if you wish. This is the advantage of using RFEM. You can design even timber members. But I suppose because this project is Kenyan project and we don't have snow load, so the snow load should be negligible. So we can just go ahead and design without having to add the roof load, but we might add the wind load. So you can go to tools. You can go to tools, generate load, wind load, flat according to EN. Okay. So you can generate the wind load. Tools, wind load for flat load. Okay. So after that, we can just go to option. So I can go to calculation. Yes. So we can go to add-on module, concrete design. RF concrete columns. Design according to Eurocode. members, all members. I'll change to BS. All right, so so to correct this error, you can see error number 1034, the line load, however, it does not belong to the surface. You just need to come here and delete these loads. Okay, delete those line load and even these other line loads on the other side. So these were the loads for staircase. So instead of line load, we will use member loads. The first option, new member load 22 here and there. Then again, new member load 11 just for the landings there and there. Now remember in our sizing, I told you that these columns, so I will select by cross section the columns only, edit, model data cross section table. Okay, let me select all that and then show selected. Okay, I want to select only those which are going up to the third and fourth floor. Right click. I want to change the dimensions, right? I want to change the dimensions. My dimension this time will be 300 millimeters by 300 millimeters. Okay. Okay. Now again, so let's view everything. Cancel visibility mode. Now let's calculate all. So now you can see the calculation is running because we don't have that error. So we need to check if there is any other error. So there is stiffness matrix is singular, the model is unstable. So this could be because of dimensions. So let's check if there is any error in the model. Model check. Unconnected members. There's no unconnected members. So maybe we should select all of these and change the form. So the form is compression. Let's change it to Berkeley. So let's use just compression, or we can just select beams. Let everything be beams. Okay, and then again holding control. Let everything be beam, and then you can come here, edit, model data. Then here at general data, make sure you check RFEM find form finding. So find the initial equilibrium shape for structure in tension and compression. Okay. So now let's calculate all. So the calculation has completed. Now we are doing the design. So we have up to 13 load cases. So we are in the third load case, the fourth. So we'll go up to 13 load cases. Almost through 9 out of 13 load combinations, not cases, combinations. 11 out of 13 combinations, load combination. Thirteen out of 13. So almost through. The fee calculation takes a lot of time, but designed by mesh, FEM mesh is the most accurate method of design. So it's calculating provided reinforcement. So we'll check linear analysis. So we're designing the columns. So it's calculating some undeformations, you can see here. This calculation can take some time, but almost through. So you can see the global deformation. You can go to concrete surface design. Let's design the concrete surface using RFEM. And then we are going to check the reinforcement, the provided against, if the design has passed, and what rebar size we should use, either T10 or T8 for our slabs. So all load combinations. Okay, so I'll go to general data. We need to change this to Euro. We need to change this to BS. So that if you go to materials, now this material is okay. Reinforcement steel grade, you can reduce it, but that is okay. Surfaces, reinforcement, So start calculations. So let's see the graphics. Let's go back to RFEM surface. See the message. Okay. Now we can check the concrete columns. Check the columns by members. So reinforcement. Some members have failed. Most members have passed. Um, so you can see the design ratio. So let's check this one. We first cancel. So we go to calculation parameters, linear analysis to calculate. Calculate. Calculation parameters. Um, so to calculate, So go to add-on module. Go to settings. Go 3D view. You can see the required reinforcement. Okay. So the columns are failing in design. So maybe we can just increase the dimensions to pass the design. So we will do design in second part of this video. Thanks for watching. See you in my next video.